Hi everyone, this is Dr. Nolly. So in today's video, in this set of videos, I'll be talking about topic 6a, which discusses basic terms and definitions in thermodynamics and thermochemistry. Now remember, in the intro video I was talking about why we need to study thermodynamics and thermochemistry, and all of it has to do with energy. So the first thing we should ask is just, what is energy, right? What do we call, what is it that we define as energy? So in physics, the energy, the term energy refers to the ability of an object, or sometimes called a system, to do work. Okay? Now work here is a symbol small w, and it actually also has a very specific definition in physics. And work is when a force, which is symbolized as F, acts on a body in a way that displaces the body a certain distance away. And that distance is denoted as d. So in physics, the equation that represents work is W equals F times d, where F is the force and d is the distance that the object is displaced from. Okay? Now if you think about this, it might sound really complicated, but really if you think about taking, if in front of you have a book, for example, think about taking that book and moving it from whatever its current location is to another location on your table, okay? Or taking it from the bookshelf and moving it to the floor. You've just done work in the physics sense of the word, okay? So you've basically put a force and you're moving an object a certain distance away from its original location. And so that's what work is in physics. And when you do that, you're putting in energy to the book when you're moving that book. And so that's the definition of energy, is the ability of an object, in this case you, doing work on another object. Okay? Now, there are two forms of energy that would be interested in. Okay? One is called kinetic energy and the other one is called potential energy. Kinetic energy is basically the energy that you get when something is moving. Okay? So anytime you're moving, for example, if you're walking, you have kinetic energy. If you're running, you have kinetic energy. If you're driving a car, the car has kinetic energy, and so on. Now, sometimes it might be a little difficult to think about kinetic energy because there are things that are moving that we don't think about as moving. But air, for example, gas particles are moving, and as a result they have kinetic energy. And we talked about this actually in the previous topic about gases, that there's an equation that represents the kinetic energy of gas particles at a given temperature. Okay? So what are the different types of energy that might be categorized as kinetic energy? Well, thermal energy is one. This is the energy as a result of the motion of particles at a given temperature. This is what we talked about when we talked about the energy of gases in the previous chapter in topic 5. We talked about gases having energy as a result of being at a given temperature, and that's what we refer to as thermal energy, and that's an example of kinetic energy. Electrical energy would be another example of kinetic energy, because electrical energy is produced when you have charges moving, electrons moving, and so that's another form of kinetic energy. Light energy is another form of kinetic energy because it's produced as a result of the motion of light particles, which we call photons, and that's what we're going to talk about in the next topic. Not this chapter, but the next chapter. Well, what about potential energy? You hear about this all the time. The definition is actually quite strict here. So potential energy is the energy that you have, that an object has, as a result of being in a certain position relative to a reference point. Okay? That could be a specific position or a specific composition relative to a reference point. So potential energy is always, it's an energy that you have as a result of being measured relative to another point, okay, which we call the reference point. Now, what are some examples of potential energy? The easiest one, of course, to think about is probably gravitational potential energy. This is a type of potential energy that is a result of the relative position of two particles that both of which have a certain mass associated with them. Okay, now a lot of times, of course, when we're talking about gravitational potential energy or gravitational energy, we're referring to the fact that all objects that are within a certain distance away from Earth, for example, everybody on the surface of the Earth, right? There's gravity pulling on it. And when we talk about gravity, we're really referring to the fact that Earth and the object, like a ball that you throw up, eventually it's going to come down. There's an attraction between that ball and the center of the Earth. Okay, so let me illustrate this in the following picture. So that attraction is what we refer to as the gravitational potential energy. Okay, you can quantify it as the gravitational potential energy. So you imagine here somebody is going on a swing. Okay, now when the person swings up to this position, this particular position measured relative to the sea level or the surface of the Earth is a certain distance away, and as a result of being in that position, that person has a certain gravitational potential energy relative to the reference position, which is the surface of the Earth. When that swing is at this level, which is, as you can see, a lower height relative to this one, then that person still has gravitational potential energy, but that value is lower. Okay, so the arrow here is a little bit shorter than the arrow here. And then when that person swings up here again, its height is, that person's height is more than at this position. So now it has a higher gravitational potential energy. So as you can see that there's 3 different gravitational potential energies here. And they're all measured, they're all quantified relative to the height, but the height is nothing more than the relative position of this object to the surface of the Earth. Okay? And that's why potential energy is always the energy that results from an object having a specific position relative to a reference point. The reference point for gravitational energy is the surface of the Earth. If you're talking about Earth's gravitational energy, if you're talking about the Moon's gravitational energy, then it will be the, you know, the actual center of the Moon is what the reference point would be. Okay. Now we can talk about other types of potential energy as well. For example, electrical energy would be energy that results, potential energy that results from 2 charges and their relative position. Okay, so we talked about electrostatic interaction, remember, in a few chapters back at the beginning of the semester, and that's really a form of potential energy because there's 2 charges, either positive negative or negative negative or positive positive, and they're either attracting or repelling each other, and as a result of that attraction or repulsion, there's a certain energy associated with that, and the repulsion and attraction is due to the relative position of these charges. If they're far away, there's less of it. If they're closer, there's more of it. Okay? Chemical energy is another one that we'll be interested in discussing, and of course that's the energy that is a result of molecule being composed of certain atoms. Okay, so certain chemical bonds result in certain amount of chemical energy for that particular molecule, and that's really what we want to be able to do at some point with thermodynamics, is to be able to quantify the amount of chemical energy that a reaction has, either requiring a certain amount of energy or producing a certain amount of energy. One of the things I want to highlight right away is that an object's internal energy, okay, which is symbolized as the letter E, is basically the sum of all the potential energy and kinetic energy that that object has. Okay, so for example, as a result of you having moving, let's say you're moving around in the you're walking from home to school. You have kinetic energy while you're walking. But because you're walking maybe at a particular height relative to the surface of the Earth, you also have potential energy. The sum of all of those potential and kinetic energies combined together gives you your internal energy. Okay, so internal energy is just kind of total energy. It's the sum of all of the potential and kinetic energy that you have. So lastly, I want to kind of point out a little bit about the different types of energy that we mentioned earlier as far as which one is potential and which one is kinetic. And these are, all of energy. They're types of energy, but each one of them belongs to either a potential energy form or a kinetic energy form.